So, today we're about the probability of multiple events occurring. So you're going to see the word "and" today. Okay? So the probability of A and B. Yesterday we talked about the keyword "or." Remember, if the probability says "or," then you add the probabilities. If the probability says "and," then you multiply. Okay? Now, two events are either independent or dependent. Independent, like you live by yourself. That means you're independent. When you fill out the FAFSA, if you could somehow prove you're independent, then that means it's only based off your income and you will get more money. That's what I do. So independent, it just means the outcome of the first event has no impact on the second event. And then we have dependent, where there is an impact. So probably the easiest way to demonstrate this is if I have 50, and I'm talking about what is the probability of drawing two hearts. Now, if I just, let me see what I get. I did not get a heart, right? Now, if I put it back and reshuffle, and then do it again, then the events would be independent because I put it back. Now, but if I drew a card and then I didn't put it back, now there's only 51 cards to pick from, and so that would be called dependent. Does that make sense? So it's basically mostly, do you put the card back or not? So, what's the probability in having children? The probability of having a boy is 1/2, approximately. You either have a boy or you have a girl. Now, I think there's more science that goes into that than that. I don't think it's exactly 50-50, but let's just say it is. What is, if you have a boy the first time, does that make you more likely to have a girl the next time? No. What if you have 5 boys? Or like me in my situation, I have 2 girls, ages 6 and 8. So I have a girl, 2 little girls. Does that mean I'm more likely to get a boy the next time? Could I get another girl, then have 3 girls, and then try again? I have 4 girls, and then try again, and then have 5 girls? Have a whole family of girls? I could. Right? Just because I've had 2 girls, that's going to have no effect on what happens the third time. Those are independent events. Okay? So, the probability of a boy is, the first time is 1/2, right? The probability of having a boy as your second child is again 1/2. If the events are independent, then we just multiply them. Does that make sense? So 1/2 times 1/2, you just multiply numerators. 1 times 1 is 1, is 4.25, 25%. Okay? Which makes sense, because if you think about it, if you have 2 children, you could have boy, 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 girl, 2 girls, or a girl and a boy. Right? That could be your order. There's no other order. If you have 2 kids, those are your options. So only one of them consists of 2 boys, 1/4. You see that? Now, 5 boys in a row, then it'd be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Or you could have just did 1/2 to the 5th power, 2, 4, 16, 32. 1 out of 32. Remember with fractions, you multiply numerators, 1, 1, 1, 1, 1, 1, multiplied is 1, 2, 2, 2, 2, 2, 2 is 32. Okay? And if you want to write it as a decimal or as a percent, I'm just going to assume you know how to do that. Okay? But this is around 0.031, so 3.1%. Around 3% chance of that happening. Does anyone know any families with all 5 boys? Who has all 5 boys? It sounds terrible. Just like having all 5 girls would be terrible. I want a mixture. I'm hoping my next kid is a boy. Even though I love both my girls, I want a boy the next time. 2 girls, and you know, being in a relationship with the girl, that's already 3. I need another guy in the house. All right. In Florida, the probability of getting hit by a hurricane, not sure where they got that number from, but we'll just use it. What is the probability that a hurricane will hit Florida every year for 3 consecutive years? Hurricanes don't talk to each other, right? Just because you have a hurricane last year does not mean it's less likely for it to happen this year. Do you agree? Just because it snowed last week does not mean, and we had a snow day, does not mean it might snow this Sunday. I don't know if you heard. Huh? Maybe we have another snow day Monday, right? So I would say these are independent. So 3 consecutive years would be 5/19 to the 3rd power. And I don't know if you know this, but a lot of my students aren't a fan of fractions. You could just type it in 5/19 times 5/19, right? And then just go math, fraction. And it'll simplify it for you if you wanted to. So math right here, and then math. Enter changes it, or you could just take 5 times 5 times 5, you get 125. 19 times 19 times 19, 6859. Reduce it if you can. Change it to a decimal if you want, or a percent, depending on what the problem's asking. Okay? Questions? So what's the probability that a hurricane will not hit Florida? Well, to hit Florida, 5/19. So not hit Florida, we learned yesterday the probability of something and not always adds to 1, right? So out of 19 years, the hurricane will hit 5 of those years, implying it doesn't hit 14 of those years. Does that make sense? So 14/19 times 14/19 times 14/19. We multiplied it 3 times because, and I'm going to be lazy this time and just put it in as 14/19 to the 3rd power. That's 14/19 times 14/19 times 14/19. So around a 40% chance, 0.40. If you want it as a fraction, that is 2744 out of 6859, which equals 0.40, which equals 40%. Yes. 14. How did I get 14 is the question. Well, the probability of getting hit by a hurricane is 5/19. of getting hit. And now it's saying, what's the probability that a hurricane will not hit? So basically, if you think of this in terms of years, 19 years go by, a hurricane will hit Florida about 5 of those years. Right? So a hurricane either hits Florida or it doesn't. Right? So what that implies is if it hits it 5 out of 19 years, then at 5 plus 14 is 19. So it does not hit it 14 out of 19. Does that make more sense? So does not is 14 out of 19. So from yesterday, the probability of something happening and the probability of something not happening always equals 1. So I basically took um, 19 out of 19, which is 1, minus 5 out of 19. We got 14 out of 19. Does that make more sense? And everything we're doing so far, I'm pretty sure we've done before. When we did questions like this. So we talked about 30 multiple choice questions. And there's 5 possible answers. How many different ways can you answer? Well, you have options, 5 options, 5 options, 5 options, 5 options. Just because you choose A for number 1, that has no effect if you choose A on number 2. So we've kind of already done this before, right? Or like we did a stop question. It's either go up, down, or unchanged. So we took 3 times 3 times 3 times 3 times 3. Because we're talking about 5 stops, right? That's essentially what we're doing today. So these are independent events. The denominators will not change. Now, let's talk about when the denominators do change. And these are called dependent. So if you're a dependent on your tax return, that means someone is paying to take care of you. Dependent events, one event does impact the other. Wish I had some cups. I would so do this experiment. 5 cups are placed upside down, hiding an object in each of them. So we have 5 cups. 1. 2. And I'll even put them inside so we can see what's inside them. 3, 4, 5. Right? 5 cups. 4 of them have candy in them. And then we'll let this be the detention. Okay, the jack. So what this is saying, they're upside down, so you can't see what's inside. 4 have a candy bar. The last is a detention. So what is the probability of revealing a candy bar? How many of these have candy bars? 4, right? 4 out of 5. So that one's easy enough. Lifting a cup and revealing a candy bar, 4 out of 5. That's 80%. That's not bad. What's the probability of lifting 2 cups and revealing a candy bar in each? So let's think about that. Again, I have these upside. The right side up on purpose. Right now, what's the probability of drawing a candy bar? 4 out of 5. Right? Do you think you put that cup back? Do I put that cup back? If I do, then these events are independent. But you're playing a game, right? Usually when you play a game, the cup's gone. Okay? Now what's the probability of drawing a candy bar? 3 out of 4. Now, 2 out of 3. 1 out of 2. And then obviously when you got to this step, would you draw another cup? No. Right? Because there's detention in there. So we just said that. So probability of lifting 2 cups and revealing a candy bar in each. Well, the first time we did it, 5 candy bars. And then assuming, because you're talking about getting a candy bar, so if you have 4 and you grab a candy bar, that leaves 3 candy bars, right? But only 4 cups. Does everyone understand where those fractions came from? Yes? Now you're down to 4 because you took 1. You had 4 candy bars. You took 1. Now you're down to 3 candy bars. If you do the math, you get 12 out of 20. 4 times 3 is 12. 5 times 4 is 20. Which reduces to 3/5, which is around a 60% chance of winning. Right? Now, what's the probability of lifting 4 cups and revealing all 4 candy bars? You go through it again. Well, the first time getting a candy bar was 1 out of 5. I'm sorry, 4 out of 5. 4 candy bars out of 5. Now there's only 3 candy bars out of 4. Now there's only 2 candy bars out of 3. Oop, I don't want that one. And then now there's 1 out of 2 with candy bars. And then your hope is that you don't have the detention card, that you don't grab that. So we just said that would be 4/5 for the first, 3/4 for the second one, 2/3 for the third, and then 1/2. You're left with 2 cups. One has a detention, one has a candy bar. 4 times 3 is 12, times 2 is 24, times 1 is 24. 5 times 4 is 20, times 3 is 60, times 2 is 120. 24 out of 120 reduces to 1/5. You have a 20% shot of winning. Does that make sense? So what that means is, basically, there's 4 of you. Say we had 1 more kid show up, and we played this game. 1 of you would win. The other 4 of you would have a detention and some candy. Does that make sense? You are dealt one card from a 52 card deck. Find the probability of drawing a card with the heart. Do you remember how many of these have hearts? Not heart, 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 not heart. There's a heart, right? Another heart. Do we remember how many of these are hearts? Huh? What? Oh, I did. Must look like a heart. I don't know why. Thank you. Do you guys remember how many of these are hearts? Yeah, 13. And you'll have these memorized after a while. But yeah, if you sort out the cards correctly, almost messed up. There's 52 cards total. And there are 13 of these that are hearts. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? 13 of those are hearts. So the probability of drawing a card with the heart, well, that's simple enough. 13 out of 52 total cards. Which reduces to 1/4, which equals 0.25 equals 25%. Right? If they ask you that way. You're dealt 3 cards from a 52 card deck. Find the probability of drawing 3 cards, each having a heart. Well, if I start out, and I should mix them, maybe I won't mix them because I want to find all the hearts again. But right now, all these are mixed. Right? What's the probability of drawing a heart the first time? 13 hearts, right? Out of 52. 13 out of total 52. And then you would assume doing probability that you drew a heart. And you're not putting it back. Now it's the probability of drawing a heart. Now you have 12 out of, how many cards are here now? You took one out. 51. And now how many hearts do you have? 11 out of how many total? 50. Because every time you draw a heart, there's one less card in the deck. So, we just said you would take 13 out of 52 times 12 out of 51 times 11 out of 50. Do the math. This becomes 11 out of 850 when you reduce it. Now this isn't the only way you could do this, and that's part of why I used to get confused in probability. I'm like, whoa, 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 whoa. That's not how you taught me before. You taught me to do this. 52, order doesn't matter, choose 3 cards. And you're picking from 13 hearts, and you're picking 3 of those. Right? Well, guess what? If you type that in the calculator, you still get 11 out of 850. So you could do it either way. It's good to make those connections. This way or this way. Same answer. It's only like a 1% shot of that happening. What's the probability of being dealt 14 hearts? Yeah. There's none, right? You can't be given 14 hearts in the standard deck of cards. So there's no possibility of that happening. Your deck's not just going to grow an imaginary heart. Okay? Now let's do the same thing. You are dealt 3 cards from a 52 card deck. And again, I'm just putting these up here. Find the probability that none of the cards will be hearts. So hearts, not hearts. 13 are hearts. How many? You want me to count them? Or do you just want me to take 52 minus 13? 39. 39 are not hearts. You draw a card. That's not a heart. Now how many cards are not hearts? How many? 38 out of 51. Because you have this card in your hand now, right? And then you draw. Now how many of those hearts? 37 out of